Hello everyone, I'm Gerald here, and today I'm going to present my assignment on Euler's method. So basically, what is Euler's method? Imagine a curve is being drawn, and then we draw different tangents on different points of the curve. If the gradient of each tangent is calculated, we can see that when the values of x and y change, the gradient of the tangent will change too. Since the gradient of the tangents actually determine the rate of the change in the value of y with respect to the change in the value of x, we can say that when the values of x and y change, it means that the rate of the change in the value of y with respect to the change in the value of x change too. So now I'm going to show you how the formula for Euler's method is derived. Now, I basically let the gradient of the tangent on the curve be m, so I just let it be equals to dy over dx. M equals to dy over dx. So now let's go to the formula for Euler's method. Yn plus 1 is the final value of y, yn is the initial value of y, m is basically the gradient, and the step size is the change in the value of x. So step size is basically the change in the value of x, as you can see on this graph. So if the gradient and step size is multiplied together, I will definitely get the change in the value of y. So now I'm going to show you how I get the value of y bracket 1. So basically, before I get the value of y bracket 1, I basically find the value of y bracket 0.5 using the formula that I got from that I got for Euler's method. So I basically let my step size be 0.5. In order for me to find the value of y bracket 0.5, I basically sum in my step size and my initial values of x and y, which is 0 and 1 first, to help me find the value of y bracket 0.5, which is basically 1. After that, I use the same formula again for Euler's method. Sum in my same step size, but this time around, my new initial values of x and y, which is 0.5 and 1 again, to help me find the value of y bracket 1, which is basically 1.25. Now, after I find the value of y bracket 1 from Euler's method, now it's time for me to do separable ODE's method on dy over dx, because I basically need to find the approximation error after that. So I basically do the separable ODE's method on dy over dx to get y squared dy equals to x dx, and then I integrated both sides to help me get 1/3 y cubed equals to half x squared plus c. Since I know that y bracket 0 equals to 1, I sub in y equals to 1 and x equals to 0, which helps me to give me this completed equation. And then I need to find the value of y bracket 0 and y bracket 1. So I need to sub in x equals to 1, which helps me get 1.357 as the value of y bracket 1. So now after that, I need to find the approximation error. So in order to find, I need to take the value of y bracket 1 that I got by doing separable ODE's method and sub in the values minus the value of y bracket 1 that I got from Euler's method, which is basically 1.357 minus 1.25, which gives me 0.107. This is the end of my presentation.